Welcome to 10 minutes CS. 1 to 77 count square submatrices with all ones. We're given an m cross n matrix of ones and zeros. We need to return how many square submatrices have all ones in it. So let's take this example. So here we can see we have 10 squares of side 1. So this will be a square in itself. Similarly, this will be also a square in itself. All these are square in themselves. So we have total 10 ones in it, and we have 4 squares of side 2. What are all these? This is one of those square. This is one of that square. We have one square here and another here. So we have total 4 squares of side 2. And we have one square of side 3, which is this one. So in total, if we add them all, 10 plus 4 plus 1, 15. So that will be the answer for it. The very basic brute force approach for this question will be that we can have our squares size from 1 till any number. That will be the maximum square that we can have in this matrix. So let's see, for this matrix we can see the maximum square that we can have is the minimum of row and column. So minimum of m cross n. So we can run a for loop or a while loop for our squares, and each time we will keep on incrementing our squares, and then we can search in our matrix. That is, we will have to run a for loop from 0 till m and another for 0 till n, and we can check if we have the element as 0, that means we cannot count it as in our square, so we will just continue. For the other case, we can check if it has a square of that particular square size. If true, then we can add it to our count. Now how will we write our this to check if the square found function? For this, we can check if the square size is 1, then we can just simply return the value at our matrix element, because in it, if it is 0, then the square size found for 0 will be 0. If it is 1, that is, we have found it. So here we are trying to find the matrix starting from ith and jth, which has a square size as our square size. If it is found, then we increase the count, else we don't. So, and we can check if our column plus square size is greater than the number of columns, or if our row plus the square size is greater than the number of rows that we have, then we can return false. Else we will check for a for using a for loop from our row till our row plus square size. Similarly, we have to go through all the columns from our column till the column plus square size, and if any time for that particular square we find any element which is 0, then we can return false, and if we have run through all that for loop, we can return true. And finally, we will just return our count value. This approach, we are running multiple for loops. So first is we have to go through all the square counts. So that will be minimum of our m cross n, and then we are going through a for loop that will be m cross n again, and in our check for square found function, we are again running a for loop from our ith till the square size. So let's say our row was we are trying to find from 0 0 till for the square size of m cross n minimum. So this for loop will run for these many times. So that will be again a minimum of m cross n. So overall time complexity is pretty high. Can we reduce it? Let's see if we can. Let's take up the same example. If we say that a particular element will store the number of squares that will end at that, so the element being the bottom right of the squares, so we see the three elements will contribute to it. The first is the above element. If the above element is 1 and the diagonal element is also 1 and this is 1, then they can form a square. So if any of these is not 1, then definitely they cannot form a square. So let's take up another element. Let's say this one. So all these three are 1, so they can form a square, right? How many squares are they able to form? 2. One is this one and another is this one. So we have to take their values into consideration. Now for this element, these three will contribute to it. So how many squares can it form? One is this one, another is this one, and another is this one. But how will we pre-compute it? So we can see that how many squares are ending here. This will be 2, this will be 2, and this will also be 2. So we can take the minimum of all these three values, and so that will be 2. So this will tell that 2 squares are ending at this, but this also in itself is a square, so we have to add 1 to it. Now why minimum? Let's see this example again with a different element. Let's say let's take this one. Now here if you see, this will be 1 and let's take this element. So this will after computation will be 2, this will be 1, and this will also be 1. So if we see how many squares are ending here, one is this square and another is this square. If we take the max of it, so this will give us 2, but we will add 1, so this will give 3. That will be the wrong answer. So we have to take the minimum number of squares, because that will take into account all the squares that are falling into its range. This 2 was added because of this square also, but that is not part of this square, right? So hence our formula will be minimum of its above, left and diagonal element, and we will add 1 to take into account the square size 1. Let's do a dry run for better understanding. For the first row and first column, we see that there is no above or above element for the first row, so this will remain as it is. And for our first column, we do not have any element to the left of it, so that will also remain same. For all other elements, we have to take minimum of its above element, left and diagonal, and we add 1 to it to get the number of squares that ends at that being a bottom right element. So we first go to this element. This is 1. So if the element is 1, then only we do all this computation, because if it's a 0, then obviously it cannot be a part of it. So let's say this is the element. So even though all these three are 1, but this is a 0, so this can't be a valid square. So this is a 1, so we can add minimum of these three, that is 0. That means it cannot form a square, so we'll just add 1 to contribute to itself being a square. Now we go next to 1. So we take minimum of these three, which will be 1, 1 plus 1, 2. Again, same, we take minimum, that will be 1 plus 1, 2. Then we take minimum, which is 0. So 0 plus 1, 1. We take minimum 1, 1 plus 1, 2. And we take minimum of these three. So that will be 2, 2 plus 1, 3. Now these are the number of squares that are ending there, and we can count all these values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this will give us 15. Do we need another for loops to add all these three? No. While doing the computation itself, we can add it to our, keep on adding these values to our count variable and finally return count. Let's do another dry run for the example 2. For this one, we see we will take the first column and first row as it is. So we see this is a 1. So we take minimum of these three. So 0, 0 plus 1, 1. And then we take, we see that this is 0. So this will be 0 only because it can't form a square. This is 1. So minimum of these three is 1. 1 plus 1 will be 2. And this is 0. So this will remain 0. Now if we will add them all, 1, 2, 3, 4, 5, 6, 7. So this will give us 7. Let's look at the code now. So first of all, we will have our row length and column length, and then we can have our square count. We can run a for loop over our matrix, and if it is first column or row, we can just add it to our square count. So if it is a 0, so we can add 0, that is, it won't be added to our square count. If it is 1, then we can add it. Else if it is other than the first column and first row, we can check if the element is 1. In that case, we take the minimum of the diagonal element, the above and the left element, and we can add 1 to it to contribute it being in itself a square, and we can add it to our square count and update our matrix value with the number of squares ending at that element. And finally, we can just return the square count. What is the time complexity for this? We are running a simple for loops here, so that will be big O of m cross n. And what is the space complexity? We do not include any additional space, just that variable, so that will be big O of 1. Hope you like the video. Thank you for watching.